Good morning, my dear friends. Welcome back to your channel of learning mathematics. So, as promised, today we will be solving the remaining part of the 6 mark questions. I'm sorry that due to some delays, we couldn't um, continue the classes for some days, but now things are all settled. We will resume with our normal classes very soon. So, alright, anyway, so 4 marks are all done for you. So let's continue with the 6 mark questions. So I guess it's today also, it might take at least maybe 1.5 hours. So I suppose you brace yourself for yet another brainstorming session. Now these are all very important questions because I believe you're already keeping a track of what is happening with the other classes, other examinations, and also I guess you can get a clear idea on what may happen. So this question bank, of course, I guess will prove to be very beneficial for you. So anyway, let's continue with the first question that we have, that is solving a system of linear equations, of course, by matrix method. So once the question says by matrix method, you cannot solve it by any other method. Okay, you have to use matrix method only. So these are the 3 equations given. So up to in class 12 we will have normally 3 by 3 matrix. Alright then, so let's begin. 1, 2, 3, the 3 equations are given to you. So let's begin. So you can just write down solution. The first question, of course, I'm not doing that A part because that is using properties of using elementary row transformation. So I guess that is slightly out of the omitted reduced syllabus with a part of the reduced syllabus, so that I guess we will be omitting for now. So most of course this is normally a very common question that is asked, that is generally used in your board exams in NBSE. So yes, and as I state, these 6 mark questions will definitely prove to be very beneficial for you. So you better prepare yourself with it. Alright, anyway, we can just continue then. This, I assume that most of you already know the basics, so I'll not be going much as like the other classes into the details of this. So we can just write the given system. The given system of equations can be written in the form Ax is equal to B. That's from the concept of matrix multiplication. So where A, of course, would be the matrix which comprises of the coefficients of the variables, that is x, y, and z. So A, first one, 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. B, you can check out the other videos also where these concepts are discussed in details. Okay, B would be the matrix which consists the constants, which comprises of the constants of the given equations 4, 0, and 2. 4, 0, and 2. And of course, X would be the matrix which would comprise of the variables, that is x, y, and z for this particular question. There can be other variables also. So now our job is, of course, solving this. What happens is by pre-multiplying by A inverse on both the sides. As we know, what we have here is X would be A inverse of B, and this is the equation that we will be using. So that means we will have to continue to find out A inverse. So now before we really proceed to find out A inverse, as we all know, we have to see whether this is a singular or a non-singular matrix. I guess this is done, so I'm just rubbing this off now. So let's find out the determinant of the matrix A. So determinant of the matrix A, just a small revision, quick revision for all, that is 1 into, of course I'll just For the first question, I'll just write in detail. 1 into, that is, omit the first row and the first column. Use this 1. Then the minor. 1 minus 3, 1, 1. Most of the students have seen minus this element. Minus 1. They end up making mistake in this portion. Now, so omitting this row and this column, that's 2 minus 3, 1, 1. 2 minus 3, 1, 1. Most of the students, they end up making mistakes in this particular, and then the whole solution just goes off. 1. So omitting this row, this column and this row, we have 2, 1, 1, 1. 2, 1, 1, 1. Just for this question, I'm just giving it to you in detail. So that's going to be 1 into 1 ones are 1 minus 3 plus 3 minus plus 1. 2 ones are 2 minus 3 ones are 3 plus 3 plus 1 into 2 ones are 2 minus 1. So this value will be 4 plus 5 plus 1. So this is how much? 10. That is not equal to 0. So as we all know, that since determinant of A is not equal to 0, A is non-singular. So A inverse will exist. Because if A inverse doesn't exist, what's the point of solving it again, isn't it? So now time to find out the adjoint of this given matrix. Time to find out the adjoint of this given matrix. So let's proceed. For adjoint, again here also I'll discuss in detail, slightly in detail. Let's find out the cofactors. Let's find out the cofactors of the given matrix. That is, I'll just write capital letters. You can use C also. That's up to you. Okay, I'll just use C. Cofactor C11 will be M11. 1 plus 1 cofactor. Of course, there's a formula as we all know it, so you can just go back and check those videos. M11, 1 plus 1 is even. So when it's even, let it be, you do not add any negative values here, so let it be as it is, positive only. M11. So minor of M11, I rubbed off that matrix. I'll need that matrix. I'll write it here once again. I guess this is done. So I'll just rub off this. I need that matrix to explain it to you. So what was the matrix for us? 1 minus 1, 1. 2, 1 minus 3. 1, 1, 1. 1, 1, 1. Okay. So minor. Again, as usual, 1, 1 means the first row, first element. Ignore its rows and columns. Find out the determinant of this. That is, do I have to write? I guess I'll just do it directly. Or okay, I'll just write down once again. Minus 3, 1, 1. For this question, some of you must be learning this for the first time. So it's actually 1 into 1 minus 1 into cross multiplication like this, no? Minus 3. So that's 1 plus 3. That's of course 4. For C12, the cofactor, that will be M12 minor, but a negative sign should come because, of course, there is a formula, no? Minus 1 power I plus j and all. So we'll not discuss that detail now. Minus. All you have to remember is simple, that is 2 plus 1, 3. So whenever it is odd, introduce a negative value. Whenever it's even, let it be as it is. Let it be the original value. So M12 again. M12, that will be 2 minus 3. 1, 1, 1, 1. So this value, 2 ones are 2, minus plus 3. This is a negative value there. So that is minus 2 plus 3 minus 5. Similarly, C13 will be M13. This time, of course, it's going to be positive because 3 plus 1 is 4. So that's even. So that will be M13. M13. Ignore its row and its column. So 2, 1, 1, 1. 2, 1, 1, 1. So 2 ones are 2 minus 1, so that's 1. So these are the cofactors for the first row. C11, C12, C13. Similarly, we will find out for C21, C22, C23, C31. C32 and C33 simultaneously. We will just find out. So let's proceed. So 1, 2, 3 done. The rest I'll do it directly. Okay, I'll need that matrix once again. So I'll draw it here again. 1 minus 1, 1, just to show you. No? 2, 1 minus 3. Because these are 6-mark questions. So very, very important questions. Okay. So next is C21. So C21, 2 plus 1, 3, odd number, minus M21. So that will be minor. So now we can do mentally M21. So ignore this row and this column. So we'll be left with 1, 1, 1, 1. These are very simple questions. Gives you 6 solid marks. Please don't mess it up. Negative value is there. Negative value. Minus 3, so that becomes plus 3. This is 1, sorry. Minus 2, so that becomes plus 2. Similarly, C22. That is 2 plus 2 even, 2, 2. So ignore its row and column, this one. So we have 1, 1, 1, 1. 1, 1, 1, 1. So that's 1, 1, so 1 minus 1, that is 0. C23, that is M23, but 2 plus 3 is even, odd, sorry. So minus M23. So that's going to be minus of M23, this. So ignore this row and this column. So this row and this column, if you just ignore, it's okay, I'll just keep on writing down the matrix again and again, no problem with that. So 1 minus 1, 1, 1. 1 minus 1, 1, 1. So minus 1 ones are 1, minus minus plus 1, so that becomes minus 2. So again, I think this is done, so I'll just rub this off. So let's just prepare the adjoint maybe here simultaneously, otherwise again I'll have to search for it. So some part already done. C1, 1, 1, 2, 1, 3 already done. That's 4 minus 5, 1. This one is also done. 2, 0, minus 2. Then almost done. I'm just writing it because at the end we'll have to write on this one. No? Next, C31. So 3 plus 1 is 4. So that's going to be M31. So now this time, okay, again I will write 1 minus 1, 1. I think I'll just remember this matrix now forever. 2, 1 minus 3, but just I keep on writing this again and again. How many times I'll write, I do not know, but I'll keep on writing. M31. So M31, 3, 1, 3, 1. So ignore this row and this column. Minus 1, 1, 1, minus 3. Minus 1, 1, 1. These days they don't make good jokes also. That's really irritating. Okay, it just keeps on anyway. So that's like 3 minus 1, so that's 2. C32, 3 plus 2, 5 odd minus M32. So that's going to be minus of M32, 3, 2. This one, 3, 2. So 1, 1, 2, minus 3. 1, 1, 2, minus 3. So that's minus 3, minus 2. So minus 5. So that's plus 5. So we're already having our elements all done now. 2, 5. Last element, C33. So that's M33. So this one I'll just do it directly. So ignore this row and this column. 1 ones are 1 plus 2. 1 ones are 1 plus 2. So that's 3. Alright? So finally, I'll just continue from here. Adjoint will be what? Transpose of the matrix formed by the cofactors that we have found. That's why I just already prepared that. Again, as I repeat, these are very easy questions, don't miss out. So in that case, I'll just continue here. Adjoint of A will be now transpose, exchanges rows into columns, columns into rows. So that's going to be 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3. So therefore, x equal to A inverse of B. So A inverse, as we know, A inverse is 1 by determinant of A into adjoint of A. I'm just doing it directly. So 1 by determinant of A was 10 into 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3 into the matrix B. What was our matrix B? Matrix consisting the constants is 402. 402. So that's going to be 1 by 10. Now this is a 3 by 3 matrix. 3 by 3 matrix, and this is 1, 2, 3. 3 by 1 matrix. 3, 3. So the new order will be 3 by 1. So that's going to be again 3 by 1 matrix. So accordingly, let's do. So this row into this column. So 4 4s are 16 plus 2 zeros are 0 plus 2 2s are 4. Next. That means we will have, of course, multiplication, I guess. That's why you can check out the other videos. A11, A21, A31. That's what we will get. So second row, first column. Second row, first column. 5 2s are 10. And this one, 1 4s are 4, 0, 3 2s are 6. So x would be 1 by 10, 20, minus 10, 10. So multiplying, we will have the value of x as 2 minus 1, 1. And what was the value of x for us? This was the matrix x, y, and z. So from equality of matrices, x equal to 2, y equal to minus 1, z equal to 1. Alright, so this is, as I say, this is a very easy question, so do not miss any part of this. Alright, you can take your time. Of course, it should not take such a long time, but you should take your time and then solve this question. 6 marks, 90% sure to come. Now, of course, after getting the solutions, you can always check the answers also, just by substituting the values of x, y, and z in any one of the equations. So, like, you can just substitute that in maybe the last equation, because the last equation seems to be more simpler. So, x plus y plus z. X plus y plus z. So, what is the value of x? 2 plus y minus 1 plus z, 1. So, 1, 1, so that's 2. Alright? Okay, alright then. So, let's move on to the next question. That is again almost from the same topic, and here also the first question we will not be doing, that is using elementary row transformations. That one we will not be doing for this year. So here also I'll just write on the equations directly. This is also solving a system of linear equations using matrix method. So let's do it quickly now, because the first one we have done it in detail. So let's do this quickly. So x minus 2y plus z is equal to 4. 3x minus y minus 2z is equal to 3. So let's continue. Let's quickly do this. I'll do it directly now. You also start doing on your own. I'll also do. Let's compare each other quickly. Let's do it. The system of equations can be written in the form Ax equal to B, where A 2 3 3 1 minus 2 1 3 minus 1 minus 2. The matrix B of the constants 5 4 3 and x of the variables x, y and z. And as mentioned, you will be using, of course, we pre-multiply by x inverse, A inverse on both the sides, so that will be x equal to A inverse of B. Actually, the equation comes like this, by pre-multiplying A inverse on both sides. So A inverse A, that's an identity matrix I. I'm just showing you for this question. So x equal to A inverse of B. That's how we get our equations. I means identity matrix, so done. Alright. So anyway, that's the part from where it comes. So this part is done. So let's go for finding out the determinant and checking whether this is a singular matrix or a non-singular matrix. It has to be a non-singular matrix, remember. So determinant of A, I'm doing it directly now. First question I've already explained. So 2 to the 4 minus plus 1 minus 3 minus 2 minus 3 plus 3. Some, of course, they write positive here, so the order of multiplication changes from top to bottom. But I use negative values so that the order of multiplication remains the same. Same in vectors also, so that there is no confusion. 3, so 1 was a minus 1 minus minus plus 6. So this value is 2 into 5 minus 3 into minus 5 plus 3 into 5. So that will be 10 plus 15 plus 15, so that's 40, which is not equal to 0. So that means A is non-singular. So A inverse exists. So for adjoint, let's start with the cofactors. So C11 as mentioned M11, C12 as mentioned M12, C13 as mentioned M13. Slight change, negative values. Alright, so these values I have already calculated in advance. First one, of course, I had to do it for you. Second one, since it's the same procedure, I have calculated it for you, so you can later on just check and confirm. Alright. So this is going to be 5, 5, 5. 5, 5, 5. C1, C21, C22, C23. That's going to be M minus of M21. This is M22. This is minus of M23. Odd number, no? And these values, if you calculate, you will get 3 minus 13, 11. 3 minus 13, 11. And finally, C31, C32, C33. That's M31 minus of M32, M33 minus, here odd minus, mod minus. And that one you will have 9, 1 minus 7. 9, 1 minus 7. Just to save some time, I have calculated in advance. I hope that's fine. And those are doubts, you can, as I mentioned, you can check out the videos on matrices. So then we have the adjoint of the matrix A would be matrix formed by the transpose of the cofactors 3 minus 13, 11, 9, 1 minus 7. So that is going to be 5, 5, 5, 3 minus 13, 11, 9, 1 minus 7. So therefore x equal to A inverse of B. So A inverse was 1 by magnitude of A, so that was 40, 5, 3, 9, 5 minus 13, 1. This is not the way to write the 5, 11 minus 7 into our matrix B. 5, 3, 9, 5 minus 13, 1, 5, 11 minus 7. And our matrix B was 5 minus 4, 3. 5 minus 4, 3. 5 minus 4, 3. So if we just multiply this, 1 by 40. 5 5s are 25 minus 12 plus 27. 5 5s are 25 minus plus 4 3s are 12, 1 left, 4 1s are 4 5 plus 3. 5 5s are 25 minus 44 minus 21, and this value, check out. 25 minus 12 plus 27, 25, 52, 3, 25 minus 44 minus 21, this value will be 40, 80 minus 40. It has to fall. 40 minus 80, 40. By 40, 40 minus 80 minus 40. 40, 80 minus 40. In that case, x value will be just multiplying 1, 2, minus 1. So this implies the value of x is x, y, and z, the variables for us. 1, 2, minus 1. So that would imply x is 1, y is 2, z is minus 1. So you can check that in any one of the equations and see whether it is verified or not. If you get time, substitute that in all the equations, of course. Alright, so let's move on to the next question. The second equation, the constant is minus 4. I think I've corrected myself, so you can just check once. You can just check once and then see. Of course, small mistakes can happen. Can you do some maths magic? Sorry, I'm not a magician and there's no maths magic. Maths is basically all about hard work, only practice and hard work. So there is no shortcut to learning mathematics. It's all about practice, 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 and practice. Only hard work pays off in mathematics. So I'm not good in all those stuffs. Maths magic, not possible. Anyway, let's go back to question number 3 now. That's from the maxima and minima portion. Application of derivatives. Application of derivatives. Question number 3a. So I'm not writing down the question, okay? I believe all of you have the copy of the question. So let's continue. Question number 3a. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r. Prove that the volume of the largest cone that can be inscribed. Mensuration basics, I guess all of you know, because this chapter again is basically more about mensuration and the second order derivative test. But more importantly, mensuration concept is going to be very, very important, because if that concept is not strong enough, you're going to have some big problems. So prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. Prove that the volume of the largest cone. What was the formula for volume of the largest cone? Basically, a cone has dimensions, radius and height. So, alright, this can be the radius. And height, of course, we don't know, so that depends on us. Height, of course, will be this one. Height of cones. Height of cone is not going to be the diameter, okay, r plus r, because maximum cone inscribed will never be at the circumference, at the edge, not possible. So height is going to be different. Height is, of course, this much, so this one. Height, perpendicular height. So that we will have to find out. As we generally do here is we try to reduce the equation which we have to transform or prove in terms of just one variable with respect to which we will try to differentiate. That's what we do, isn't it? So for a cone, for volume of a cone, we will have two dimensions to sort out, that is radius and height. Now either one we will have to convert with respect to either one. So let's see which one would be more helpful for us. So if we just, there are many ways in which we can do. Maybe if I can just assume this as x. We can just assume that as x. So I guess sorted out, because I'll just do it here. Okay, anyway. So let me just name the triangle A, B, O. So this is a right angle triangle. So radius we can find out. We can find out any of these quantities using Pythagoras theorem. So anyway, let R be the radius of cone and H be its height. Radius of sphere already given, capital R, so that remains a constant since it is already given. So now what we can have is in triangle AOB, what we can have is certain, like r square is equal to x square plus r square. So we might just need this equation here and there. So we'll just let it be, we'll keep it, and then let's see what we have. Alright. Now, volume of largest cone, that's our equation that we have to solve. V is generally given by 1 by 3 pi r square h. So volume will be 1 by 3 pi. Now you decide which Because here we have now two parameters, r and h. Now it's up to you to decide which one do you want to convert, because I need only one parameter, one variable with respect to which I will start differentiating. So till you reduce this equation in just one variable, you will have to just go on solving and simplifying and find out until this equation reduces to just one variable. So there are many ways in which we can do. So you see what we can do here. What can we do? There are many things which we can do here. Okay, r square, using this equation, maybe I can write r square minus x square, and height can be written as r plus x. I guess that's fine. There can be other ways also. This is just one of the ways, isn't it? R square can be written as r square minus x square, and height means height of the cone, so this is r plus x, using the parameters, using the dimensions, isn't it? I think this is also fine. As I say, there are other ways also. Okay, tomorrow you tell me to do it, I might just do it in some other way again. So, alright then, so almost the equation is converted in just one variable, because r is a constant, because this is the radius of the sphere, that remains a constant. So we have just one variable, that is x. So our job is done. So maybe we can just multiply and get an equation. 1 by 3 pi. So that's going to be r cube plus r squared x minus x squared r minus x cube. That will be easy for us to differentiate. So our equation is ready. Let's start the test. So differentiating both sides. Now differentiating both sides with respect to x, because x is our variable here. So 1 by 3 pi r cube, that's 0, constant. We'll have here r squared minus 2xr minus 3x squared. So the value of the first order derivative is pi r squared minus 2xr minus 3x squared. So that's the first derivative. We will be using second derivative test here. Alright, so let's find out the point for maxima and minima first. For maxima, and I need a whiteboard very soon, because this chalks keep on degrading. For maxima and minima, for maxima and minima, the first derivative should be equal to 0. So that implies, I'll just do it here, 1 by 3 pi r square minus 2xr minus 3x square is equal to 0. So now let's solve and get some points. R square minus 2xr minus 3x square is equal to 0. So that's r square minus, let's try to solve this. This one maybe I can just write 3. Try to solve that. Instead of this, if we can just write r square minus 3x square minus 2xr, just arrangement, nothing much. R square minus x square minus 2x square minus 2xr equal to 0. R square minus x square minus 2x, that will be x plus r. equal to 0. Nothing much, just some arrangements and just some simplifications, trying to get some points here. So this can be written as a plus b into a minus b minus 2x x plus r equal to 0. So we shall have x plus r minus x minus 2x equal to 0. So we shall have x plus r or r minus 3x equal to 0. So in this case, either x equal to minus r or r equal to 3x, and this is not possible because radius cannot be negative, so as well as height also cannot be negative. So we end up with a second form almost rubbed off. Okay, this was, first order derivative. So that means we have r equal to 3x, or that implies x is equal to r by 3. This is our point of maxima or minima. We have no idea so far. So now, what we will do is differentiate this twice. Go for the second order derivative. So that's again 1 by 3 pi. I'm just going to use this equation. So that's 0 minus 2r minus 6x. So that basically leaves us with 1 by 3 pi minus 2r minus 6x. So now our job is to check the value of the second order derivative at x equal to r by 3. So that's going to be 1 by 3 pi minus 2r minus 6 into r by 3. So that's 1 by 3 pi minus 2r minus 2r. So that is going to give me minus 4 pi r by 3. So constant radius cannot be negative. So definitely this is a value that is of course always going to be less than 0. So thus x equal to r by 3 is a point of maxima. Is a point of maxima. So now what are we supposed to do? That at this point what should happen is volume of sphere should be equal to 8 by 27 of the volume of cone should be equal to 8 by 27 of the volume of sphere. Alright then, no problem. Let's prove. So, alright, what is volume of sphere? That's nothing much there, 4 by 3 pi r cube. So our volume of cone 1 by 3 pi r square h. So our equation was basically slightly different after substitution. There was 1 by 3 pi r square minus x square x plus r. So let's just substitute the values and see 1 by 3 pi r square. I need in terms of r. X was, what was the point that we got? X r by 3. R by 3 whole square. r by 3 plus r. Let's quickly solve this and prove 1 by 3 pi 9r square minus r square by 9. I'm just doing it directly. Class 12, I guess you can do these calculations by 3. So that's 1 by 3 pi 8r square by 9 into 4r by 3. So if we leave 8 by 27, what shall we have? 8 by 27, 9 to 27. So 1 by 3 pi r cube. 4 by 3 pi r cube. So that's the proof. That means volume of cone is equal to 8 by 27 of the volume of the sphere. Alright, so it's not a difficult question. Of course, these questions are simple. These are not complicated questions at all. Alright, so if you're done, you can get ready with the next question. That's number B. Okay, number B. Show that the semi-vertical angle, question number 3B. Show that the semi-vertical angle of the cone of maximum volume, semi-vertical angle of the cone of maximum volume. So if this is a cone, this is the vertical angle, semi-vertical angle means half of the vertical angle. That means if we assume this to be alpha, this is L, this is H, this is R, no? For a cone. Vertical angle is this one, semi-vertical angle means this one, half of this angle. So show that the semi-vertical angle of a cone of maximum volume of given slant height. So here slant height is the constant, is tan inverse of root 2. That means alpha is tan inverse root 2. That should be our point of what? Maxima. That should be our point of maxima. No problem. Let us do. So maybe I'll just name this A, B, C. So this is of course becomes a 90 degree. Alright, so let L, H, R be the slant height. Almost got. Slant height, altitude, and radius of the cone. Alpha be the vertical, semi-vertical angle, semi-vertical angle. And alpha be the semi-vertical angle. So now let's see again. So you have to prove that the volume of the largest cone. So here also again 1 by 3 pi r square h. So here also you have two dimensions, radius and height. So we need to have one common parameter. So this time here I will, since I need from somewhere, I need to bring in this alpha also, semi-vertical angle also into the frame. So what I'll try to do is I'll derive radius and height just like in physics, resolution of vectors and all, with respect to alpha using this triangle, right triangle ABC. So in right triangle ABC, I'll just show you, but most of you know it. What will happen? So it's something like this. Our right triangle is something like this. This is my alpha. This is perpendicular, so alpha is at A, this is C, and this is B. So BC is R, AC is H. I need radius and height. So what I'll do is one by one. We know sine of alpha is, let's say, L. So sine of alpha is BC by AB. So in that case, sine alpha will be BC is R by L. That means R can be written as L sine alpha. And similarly, cos alpha is AC by AB. So cos alpha is equal to, this looks like L, alpha. Cos alpha equal to AC, H by L. So that means H is equal to L of cos alpha. Because when I do that, what happens is volume of cone becomes 1 by 3 pi r square h. You see what happens. In that case, it becomes 1 by 3 pi r L sine alpha h. L, I think this is done. L cos alpha. So what happens here is L is a constant because slant height is already given to us. So only alpha is the parameter here. So we are left with just one variable so that we can differentiate. So V equal to 1 by 3 pi L cube sine square alpha cos alpha. Alright, so let's begin our test. Now let's differentiate with respect to our parameter alpha. Alpha or theta or whatever you use, okay? Twice product rule, twice sine alpha cos alpha, twice sine alpha cos alpha plus sine square alpha minus derivative of cos alpha is minus sine alpha. So 1 by 3 pi L cube twice sine alpha cos square alpha minus sine cube of alpha. This is the first derivative. So what shall we do? For maxima or minima, dv by the first derivative should be equal to 0. So this one equal to 0, done. I'm just doing it directly. 2 sine alpha cos square alpha minus sine cube alpha should be equal to 0. Twice of sine alpha cos square alpha equal to sine cube alpha. 2 cos square alpha is equal to sine square alpha because sine done. So we'll have 2 equal to, just simplifying, sine square alpha by cos square alpha. So we will be left with tan square alpha is equal to 2, or tan alpha equal to plus or minus root over of 2. So it has to be positive semi-vertical angle. So alpha equal to tan inverse root over of 2. It has to be positive because semi-vertical angle cannot be negative. So we have a point of maxima or minima. We do not know. We will have to check. Now for that, we'll have to go for the second order derivative. That is, and so 1 by 3 pi L cube. So again, product rule, twice sine alpha twice of sine alpha 2 cos alpha, derivative of cos alpha is minus sine alpha plus cos square alpha, derivative of sine alpha is cos alpha minus this one 3 sine square alpha, derivative of sine alpha is cos alpha. That will be 1 by 3 pi L cube 2 2 to the 4 sine square alpha cos alpha plus 2 cos cube alpha minus 3 sine square alpha cos alpha minus. So that's going to be 1 by 3 pi L cube 2 cos cube alpha minus 7 sine square alpha cos alpha. So 1 by 3 pi L cube. We can just reduce this a little bit because we know we have already seen that tan square alpha is equal to 2. That is sine square alpha by cos square alpha is equal to 2. That means sine square alpha can be also written as 2 cos square alpha, just for reducing the equation I mean. So that means twice cos cube alpha minus 7 sine square alpha I can write as 2 cos square alpha cos alpha, just for simplification. 1 by 3 pi L cube, because in that case what happens is cos cube alpha minus 14 of cos cube alpha. So then that becomes second order derivative 1 by 3 pi L cube minus 12 cos cube alpha. So 3 4s are 12, so that's minus 4 pi L cube cos cube alpha. The smaller the equation we have, the better for us, no? So that's why. So the value of this alpha equal to tan inverse root 2. This of course will be minus 4 pi. we don't have to calculate, okay? We just have to see to it that this remains negative value only. You're not supposed to expect it to solve and find out. So at alpha equal to tan inverse root 2, or there are other ways to solve also if you wish. You can use any one of these equations. That is cos alpha, or tan square alpha equal to 2. You can use any one of these equations. Tan square alpha equal to 2. And substitute and solve, you will get the equations. But see, semi-vertical angle, one concept that you have to understand is semi-vertical angle. This will always be what? Between 0 degree and 90 degree. It will not be beyond that. So in the first, that means we are going to be discussing about the semi-vertical angle in the first quadrant only. So in the first quadrant, what happens is cos value will always be positive no matter what happens with the angle of alpha. I hope you understand, isn't it? Because alpha is about the semi-vertical angle of a cone. Semi-vertical. I mean, not what I'm trying to tell you is you don't have to solve and find out. Sometimes we can just assume things without actually solving it, no? Especially for this kind of questions. So semi-vertical angle of a cone, definitely this cannot be more than 90. It has to be between 0 and 90 degree only. So that means it's in the first quadrant. In the first quadrant, we know that for all values of alpha or theta or any angle, cos will always give you positive values only, no matter q, powerful, whatever. So this is always positive, constant, L can never be negative, pi constant, 4 is a constant, that means minus. That means this value, no matter what, will always be what? Less than 0, no matter what the value of the angle is. As long as, of course, we're talking about a semi-vertical angle. If the angle that we're talking about is going to the second, third, fourth quadrant, yes, in that case the concept will change again. But that's not what we are discussing here. We're discussing about the semi-vertical angle here, isn't it? So that's why no need to solve. I hope you understand. I hope you get my point here. So this is, of course, what? Less than 0. So therefore, B is maximum at alpha equal to tan inverse root over of 2. That should be fine. Alright, so let's get ready with the other question. Question number 4. A. So let's get ready with 4A. In the meantime, I'll just have a glass of water and I'll be back. So just a minute. So let's get to question number 4A. I think it's time to get a whiteboard. this job is really turning out to be really dusty. I have to keep on dusting it. Hopefully I'll get. Alright. What do we have here? A wire of length 28 meter. A wire of length 28 meter is to be cut into two pieces. So if we cut one as x, the other will be simply 28 minus x. One of the pieces is to be made into a square. Let's say that this x will be used to make a sphere. That means in that case the perimeter of this square will be x. And the other case, and the other into a circle. The remaining part, that means the circumference of this circle is going to be 28 minus x. Not a big problem there. Isn't it? I got your question, no? A wire, we cut one wire, we make a square, another wire, we make a circle. So that's the perimeter only. Perimeter means total length of the wire only. First, what should be the length of the two pieces so that the combined area of the square and the circle is minimum? Let the wire of length x be cut to make a square, and length 28 minus x be cut to make a circle. So perimeter of square is x, that is 4 into side is x, that means side of the square is x by 4, and circumference of circle is 28 minus x, that is 2 pi r is equal to 28 minus x. That is the radius of the circle will be 28 minus x by 2 pi. Alright. And why are we actually finding out the side and the radius? Because as per the question, if you have read it properly, we have to prove that the combined area of the square and the circle is minimum. Not that we have to prove, we have to find out how much length should be cut so that the combined area of the circle and the square turns out to be minimum. It's just the same anyway. Alright, so let's see. Let's start our test. I'm following the system. Talk less, work more on this question. There's nothing much to explain here. A very simple question, this one. So let's finish it off. Hope and pray that you get this question in the exams. It will depend on how hard you can pray. This value also, of course, is always going to be greater than 0 no matter what happens, because 1 by 8 constant, 1 by 2 by constant, no matter what the value of x is, it is going to be constant only. Greater than 0. So thus we have our value of x, which is supposed to be cut so that the combined area becomes minimum. Maximum, maximum, minimum. Alright then, so that's the question. Let us move on to the next question, that is number B. Alright, so what do we have with the next question? I guess all of you must be also very tired, isn't it? Kaisa, hey, sup, look, everyone fine, active. Jati, this morning you're not talking. You're sad or what? Alright, good to know that you're fine, because if you're fine, then I'm also fine then. I guess your studies are going on well, all of you. I hope so. Just now, about, I guess, 2 weeks, excluding this week. Yeah, about 2 weeks only left, so prepare well, prepare well, work hard. Yeah, definitely give an emphasis on the what do we say, the question bank. Okay, all right. Anyway, some of you must be thinking, why is he talking so much and all. All right, let's continue. The last question of this maxima and minima, that is, show that the right circular cone of least curved surface and given volume has an altitude equal to root 2 times the radius of its base. Show that the right circular cone of least curved surface and given volume has an altitude equal to root 2 times the radius of the base. So we do have, what do we have? We do have a cone. So we have a cone. So definitely, as we mentioned, cone means L, H, R, all these dimensions will exist. Volume is given here, and so we are supposed to prove that the altitude is equal to root 2 times of the radius of the base. We have to prove that the altitude is equal to root 2 times the radius of the base. That is, H is equal to root 2 times of R. So let's see how we can prove this. So volume is constant here, so that means we are expected to use this particular equation of volume. So anyway, let, as usual, L, H, R be the slant height, comma, height or altitude, and radius of the cone. Some dimensions that we know, that is L is equal to H square plus R square, and since volume is given, that is 1 by 3 pi R square H. Or here in this equation, we might just need this 1 by 9 pi square R power 4 H square. Or we will also be using this equation 9V square pi square R power 4 is equal to H square. We will be using either of these two equations. So these things are actually given to us. These values are given to us. So that's why they would tell us, and that's why they would give us, isn't it? That the volume is constant. Otherwise, why would they just say that the volume is constant? Is it? So that is what is the general idea. So that's what we will be solving. So v will be constant here. So anyway, let's begin. So now what are we supposed to prove? We are supposed to prove that the surface area is minimum when h is equal to root 2 times of r. When h is equal to root 2 times of r. So now, curved surface area, let's say S, will be now pi r L. Curved surface area now will be what? Pi r L. So now we will have to solve this. So that's going to be S will be equal to pi r L. What was the value of L? That will be what? Root over of h square plus r square. So again here, as I mentioned, what are we generally trying to do? Reduce the equations in terms of just one variable. So we'll have to try everything to reduce the equation in one variable only. So L again I cannot afford to have. So either it's h or r, either way. So now what I'll do is I'll square both sides. Squaring both sides, r square, h square plus r square. So now here, pi square r square. So that's why the value of h square will be required here. We will keep on using these two equations. Pi square r power 4 plus r square. So we will assume okay, s square to be another constant, let's say z, doesn't matter, it's alright, okay? We will just assume s square to be z, so that's equal to pi square r square. We can just take the LCM, anyway we'll just take the LCM and since pi square r power 4, 9b square plus r pi square r power 6. So in that case, pi square r square. So we'll be left with z is equal to 9b square plus pi square r power 6 divided by r square. So that's going to be 9b square r power minus 2 plus pi square r power 4. So this is our equation. So this question is slightly different. We have to do it in a different way. So now, simple differentiate with the parameter with respect to r. So that's 9b square minus 2r power minus 3 plus pi square 4r cube. So dz by dr is going to be equal to minus 18 b square r power minus 3 plus 4 pi square r cube. So for maxima or minima, what do we do? For maxima or minima, equate the first order derivative to 0. So that's going to be minus 18 b square by r cube plus 4 pi r cube is equal to 0. Let's solve this and see what we can have. So now again, going back, minus 18 by r cube, b square value again I'll substitute back again. B square value again I will substitute back again. So that's going to be b square. What was the value of b square? That was 1 by 9 If I'm not mistaken, it was 1 by 9 b square value, 1 by 9 pi square r power 4 h square plus, so that was the value of b square, plus 4 pi r cube is equal to 0. So 9 2s are 18, r cube r, so we'll be left with minus 2 pi square r h square plus 4 pi r cube is equal to 0. Now let's just simplify this. So minus 2 pi square r h square. You can do this in your own ways. Minus pi r cube. This is of course square, 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 square. Pi square, 2, 2, 1 r square. So you are left with h square is equal to 2 r square. So then that leaves us with h is equal to root over of 2r square. So that's going to be root over of 2 into r. So we almost have our actually desired point. क्या सर अकेले अकेले पढ़ रहे हो तो क्या करें? आओ एक साथ पढ़ना है तो आओ बैठो पढ़ो एक साथ. So this is our point. So now let's go for the second order derivative. So now derivative of what was that? Z, isn't it? Z with respect to what was our variable? It was r, wasn't it? Yes, r square. The r square is equal to, okay, I forgot the equation. What was our derivative? Minus 18. I'll just write once again because I forgot it. Minus 18 b square r power minus 3, wasn't it? Minus 18 b square r power minus 3 plus 4 pi square r cube plus 4 pi square r cube. So let's differentiate this once again. Minus 18 b square minus 3 r power minus 4 plus 4 pi square 3 r square. So that's plus 3, it's our, how much? 3 8s are 24, 2 left 54 b square by r power 4 plus 12 pi square r square. So now here I guess you can easily make out that this value, no matter what happens, but anyway we'll just write down because that is a test. At h equal to root 2r, we don't have to write anything. This will be of course always okay. 54 b square by r power 4 plus pi square r square. Remember, no need to convert because this is always going to be what? Greater than 0, because see, volume can never be negative, radius not negative, pi, these are all constants, r also, this is also radius, this is not going to be negative. So definitely yes, that's the solution. At this point is always going to be maximum. So therefore curved surface area of what was the question? Curved surface area of, least curved surface area of cone. Least curved surface area of cone has an altitude. What was the question? Has an altitude equal to root 2 times the radius. That is, h equal to root 2 times of radius is the point of minima. Alright, so that's the question. So now we are left with the other set of questions. That's from the area of bounded regions. That's from the area of bounded regions and three-dimensional geometry. So I think that we will continue in another session only, in another part only, because it's almost been 1.5 hours. I'm also tired. I guess you also may be tired. So I guess that's enough for today. So we can just practice these questions. Maybe tomorrow we'll have another session on the second part of the remaining questions. Alright, so till then, take care, study well, have a good day all of you, and hope to see you very soon again. Alright, so bye bye. See you, take care.